Welcome to AI Frontiers, your deep dive into the research shaping our future. Today we're synthesizing cutting-edge advancements in computer science and artificial intelligence, focusing on a significant collection of papers released around November 24, 2025. We'll explore the evolving landscape of AI and uncover key themes and groundbreaking discoveries. Imagine this: a single misplaced comma, a simple typo, could potentially lead to millions in financial losses, or even a critical system failure. This isn't science fiction, it's a surprising reality in the complex world of AI development and coding. The stakes are very real in AI and software, and this is the frontier of intelligent machines. Our mission today is to decode AI's latest advances. We're exploring a curated collection of AI research papers with a special focus on advancements published around November 24, 2025. The goal is to synthesize these complex findings into a clear narrative, helping us understand the direction of computer science and AI, and identify key trends and their implications. The field of artificial intelligence, often categorized as computer science, artificial intelligence, or cs.AI, represents the core pursuit of building machines that can think, learn, and act intelligently. Imagine it as an immense, ever-expanding library, where each new discovery, each new algorithm, represents a step towards smarter machines. AI already powers so much of our modern technology, from the recommendations guiding our choices to the complex systems driving scientific discovery. Today we're opening some of the newest volumes in this library. Our first major theme is the sharpening of AI's reasoning abilities. Researchers are moving beyond mere pattern recognition towards true understanding and explanation of complex situations. This means teaching AI to understand the why, not just the what. A prime example is the paper Introducing Visual Scenes and Reasoning, a more realistic benchmark for spoken language understanding, which introduces datasets with visual context and explicit reasoning explanations, pushing towards AI that comprehends world nuances like a detective. The second dominant theme is efficiency and scalability, particularly for large language models, or LLMs. These models are incredibly powerful, but they can be computationally demanding. Researchers are focused on making these giant engines faster and more economical to run. Yejing Wang's paper, NEZHA, a zero-sacrifice and hyperspeed decoding architecture for generative recommendations, exemplifies this by achieving breakneck speeds for recommendations without sacrificing quality, akin to giving a powerful engine a turbocharger. Our third key theme is multimodal understanding and generation. AI is increasingly learning to orchestrate information across different senses, combining text, images, and other modalities, much like a conductor leading an orchestra. This is demonstrated in papers like Animo, Collaborative Visual Language Reasoning and Navigation via a Multimodal World Model, and Magma EDU, Multi-Agent Generative, Multimodal Framework for Text, Diagram Educational Question Generation, showing AI that can read, see, and explain relationships between different forms of information. Let's highlight some key findings that represent mini-stories of innovation from recent research. First, realistic benchmarks like Verslu are moving AI evaluation beyond simplistic scenarios, making them more akin to real-world interactions. Second, accelerated LLMs, as shown by NEZHA, demonstrate hyperspeed inference without quality loss, addressing critical latency bottlenecks. Third, structured reasoning is advancing with vision language programs, or VLPs, enabling systematic visual deduction. Fourth, theoretical foundations are being strengthened, with active inference is a subtype of variational inference, unifying decision-making under uncertainty. Finally, Magma Edu is pioneering multimodal content for more engaging and effective education. Our first paper of the day is Introducing Visual Scenes and Reasoning, a more realistic benchmark for spoken language understanding, by Di Wu and colleagues, published November 24, 2025. The primary objective here is to improve spoken language understanding, or SLU, evaluation. Current SLU datasets are often too simplistic, failing to capture real-world complexities. The method involves the VerseLU dataset, which integrates visual context and explicit reasoning by leveraging LLMs for generating realistic scenarios and explanations. This research paves the way for more natural, human-like AI assistance. Next, we examine LMCSEC, Empirical Evaluation of Security in C++, code generated by large language models by Mohammed Usman Shahid and colleagues, also from November 24, 2025. The objective is to empirically evaluate the security of AI-written C++ code, addressing the critical need for secure software development practices as AI becomes more involved. The methodology involved categorizing weaknesses using CCBUs and analyzing code from 10 LLMs. The finding is sobering. A significant number of vulnerabilities were found in the generated code, providing crucial data for the safe integration of AI in coding. Our third paper of the day is Synthesizing Visual Concepts as Vision Language Programs by Antonia Wust and colleagues, released November 24, 2025. The objective is to enable systematic and interpretable visual reasoning in vision language models, or VLMs, addressing inconsistencies in their current outputs. The method utilizes vision language programs, or VLPs, to translate visual information into executable programs. Experiments show the VLP approach outperforms direct prompting on complex reasoning tasks, offering a path to more robust, transparent, and systematically reasoning VLMs. Looking ahead, the future directions in AI research are incredibly promising. We anticipate continued advancements in multimodal AI, with seamless integration across all senses, and a strong push towards explainable and verifiable AI, driven by the demand for trust and safety. Efficient AI will be vital for the widespread adoption of LLMs, and will see increasing focus on AI for societal good, addressing global challenges. Deeper theoretical understanding will also fuel more principled AI design. In conclusion, AI is becoming more capable, practical, and grounded in reality. The progress in benchmarks, efficiency, and reasoning is remarkable. However, significant challenges remain in interpretability, trustworthiness, and ethical implications. The focus is clearly shifting towards developing AI that is not only functional, but also reliable, secure, and ultimately beneficial for humanity. Stay informed and engaged with AI's transformative journey. This presentation was crafted through AI synthesis, utilizing models like GEMIDNI-2.5-FLASH-LITE for content development and Deepgram for audio narration. Image generation was handled by OpenAI, and the synthesized content underwent review by a human expert. Please note that despite these processes, some oversights may exist. All references have been provided. In this podcast, we bring you the latest breakthroughs in computer science and AI, straight from the arXiv preprint server. From neural networks to quantum computing, we simplify complex research so you can stay ahead. Whether you're a developer, researcher, or tech enthusiast, AI Frontiers keeps you informed daily. Thanks for listening. If you enjoyed this episode, subscribe for daily updates. See you tomorrow with more cutting-edge AI insights. Stay connected with AI Frontiers. Subscribe to our channel for more insights into AI research. Our title is AI Frontiers, and our description is Dive Deep into the Research Shaping Our Future. Explore the latest breakthroughs in artificial intelligence and computer science. Join us as we navigate the ever-evolving landscape of AI.